Welcome back to Adam Saruwatari Xtreme. There have been numerous requests to take a closer look at the NSX Pro Car, so I brought out one of the NSX Pro Car spare engines. This way, we can take a look at what modifications were done to the valve train, and also I will adjust the valve clearance. This will translate to those of you that have NSXs or are potentially buying NSXs. You can keep this information and possibly help you to save some money. I talk a lot about my good friend JC. For those of you that know him, he needs no introduction, but those of you that aren't familiar with him, it'd be great to get some background information. This way you can understand his credentials and why he was so pinnacle in putting this combination together for the Pro Car. In order to do that, we would need to go back in time. And I guess for all intended purposes, I would be the equivalent of Marty McFly. JC would be the equivalent of Doc Brown, just a whole lot cooler, and instead of being an expert in time travel, an expert in all things that are engines. And of course, we would need to tap on my friend Abel, who was and is the rotary god. But a long time ago, when I was running the RX-7 and Abel was running the R100, we were hanging out at where AEM used to be. JC owned AEM in Compton. And as usual, hanging out with Abel, we were typically either eating or at the dyno. And in this particular case, at the dyno, where he continued to make more and more power, infinite power, endless. That was basically the definition of hanging out with Abel. But on this particular day, JC was down there at that time outside washing his Spider Eclipse, which it was the car to have at that time. And since I was taking a break, he offered me some advice on two things. One being women. And unfortunately, I wasn't smart enough to take that advice, which would put me where I'm at today and where JC is at today. And the other was, he had told me that he had built a 3-liter NSX engine that was making over 1,000 horsepower. And would I be interested in putting it in anything? At that time, I was just more interested in trying to keep the RX-7 together. But fast forward, when the RX-7 got into the 8s, I had pretty much reached the limitations of the stock chassis, and I was faced with a decision whether to back half the RX-7 or to build a complete new car. But I really love the RX-7 and always wanted the option to be able to put it back to a street car. I didn't know if I'd ever do it, but I knew back halving it would take that option away from me. So I opted to go to a new car. The problem was Abel was already building his RX-7, and Mazda was already fairly tapped, splitting support between he and I. The man in the position at Mazda Motorsports at that time was Steve Sanders. Super nice guy. I don't know if he'll ever see this, but I really appreciate all the help he offered me. But I realized that it would not do the industry any good to have two RX-7s from many aspects. One being both of us fighting for the same type of sponsors. The airtime on ESPN2 would be less likely with two of the same type of car. So I knew that for the industry to grow, I would actually have to have some sort of different car. And the industry needed more manufacturer support, which of course equates to more dollars. So for me, it was a natural choice. I always loved the NSX, so I decided to go with an NSX Pro Car. I needed a power plant, and I had never built an overhead cam piston engine, let alone something as sophisticated as the NSX. Luckily, I remembered my conversation with my good friend JC, got in touch with him, and he was nice enough to help me to get my program together. It was groundbreaking. At the time, he was the man and still is the man, but at that time, there was no one experimenting with the NSX engine. I mean, in the world, even Honda would come to him to ask questions. It was quite phenomenal, and I will eternally be grateful for him to help me out to achieve what I achieved. But specifically today, talking about the valve train, we can kind of go over some of the things that he did. Now, he taught me everything. So initially, when the Pro Car was coming together, it's about a 3.5-hour drive. He was coming out once a week to keep my program alive. And then he got a Ferrari 550, a gorgeous car. That would be 2 hours or less. But either way, the drive still wore on him. So eventually what happened was that he decided it would be a much better idea to teach me to do everything, which I'm grateful for. It was a heck of an experience, but I knew nothing. So I'm sure it was quite frustrating for him to try and teach me everything. But after about the first 6 months, I was building everything here myself. But of course, under his advisement, he was still overseeing everything that was done. And specifically in the valve train. The original NSX race engine that JC built wasn't specifically designed for drag racing, so there was still quite a bit of R&D to do. And the first stop was JC had to meet with IBOC, where they worked together to design a special valve spring that would hopefully be able to withstand above 9,000 RPM. The next question became VTEC. The NSX was one of the first cars to offer VTEC, and that was a great time when Honda was so performance oriented. Today, their focus is much different. As most of you know, the environment is number one, which is really, really exciting to me. But what we had to do was figure out if we were going to use it or not. And JC, being the super genius engineer that he is, makes me test everything through and through, and I mean everything. So those of you that are familiar with VTEC, please bear with me for a minute. Those of you that aren't, let's go over a quick overview just so you can understand what was going on. So in the back of the cylinder heads, these are block-off plates. This is where the VTEC solenoid goes. It's controlled by the computer. When it opens, it sends oil flow through the rocker shaft. These are the rockers. Of course, you'll see there are 3. The outer 2 are the primaries that run on the primary cam lobes, and the center is the VTEC lobe, the center rocker. And what happens is, when the solenoid opens, it sends pressurized oil through there that sends a pin through and locks them together. So that way you're riding on the VTEC lobe with more lift and duration. There was a lot of discussion as to what benefit it would have, and JC wanted to make sure that it would not be a benefit to the anti-lag system before he made any changes. So what we first did is we ran the primary lobes on the anti-lag, but testing back to back with the VTEC, we still were making around 16 pounds of boost. So at that point, he felt that it really wasn't going to be a benefit and it could possibly be more issues. I ran a Motec engine management system, so we were controlling it with the Motec. And we even actually did all sorts of crazy things where we would run it and the Motec actually could change things as the NSX was shifting gears, so we were changing back and forth. But after we had, what JC had believed, exhausted checking into everything that could possibly be an advantage, he came to the conclusion that it was better just to run on the VTEC lobe. So what we did was we blocked off these plates, removed the solenoids, and we took this 10 millimeter by 40 millimeter pin and we just pinned them together. This way we were always running on the VTEC lobe. All of you that are and have been factory supported know that manufacturers want you to use as many OE components as possible. We went with the 3-liter head, and JC decided to use the 3.2 liter intake valves, which are 36 millimeter versus the 35 millimeter standards in the 3-liter head. And he also went with the standard exhaust valve. This setup worked great to 9,000 RPM, but above 9,000 RPM, we were seeing evidence that the valves were floating. So the next thing he did was he had custom titanium seats and retainers made for the valve springs. This was great because it got us up to about 9,200 RPM before we were seeing any definite evidence of floating the valves. However, JC wanted to twist it to 9,800. And that wasn't going to happen with the current setup. So he started looking into everything, and what he assessed was we were carrying too much weight on the rocker side because we were running the VTEC and the primaries. So he advised me that he needed to go meet up with his friends at Webcam, and I was able to be involved in that, and very nice people there, super, super intelligent. And what they determined was that it would be better to get the lift and duration in the cam lobes that we wanted on the primaries and remove the VTEC lobe altogether. And that's exactly what they did. So that being said, you could see that if you remove the center rocker, you're not carrying all this weight. You're only carrying the primaries. So what they did was they modified the rockers to get the ratio that we wanted, and they built these spacers. Therefore, we saved the weight and we were getting more lift and duration to the spec of what JC figured out by working with webcam. I'm sure they told me that spec, but it has been so long I cannot remember. But I'm quite sure JC, having a steel trap for a mine, will remember. So what they did was they removed the center lobe, the VTEC lobe, and then they built up and modified the two primaries to give the lift and duration that JC wanted. The new setup worked out amazing and was a hot ticket. I hope that the background and credentials of JC will give a little bit more of a personal touch when I reference him when we're talking about the NSX, because he was such an important part of my success, and to this day, we're still really close friends. Now what I will do is go over this NSX engine and do the valve adjustment. This way it will help all of you if you want to do it in your NSX or if you're potentially going to do it in the future. We will start by removing the coil cover. So we will use a 10mm socket and remove the 4 bolts and the 2 nuts in the center when the cover comes off. After the cover's off, you'll see on the 2 center studs there's going to be 2 spacers. You'll pull those spacers and set them aside as well. Once the coil cover is removed, you'll have access to all 3 coils. Each coil has 2 bolts holding it down. So use a 10mm socket, pull the 2 bolts, disconnect the connector gently from the harness, lightly wiggle the coils, remove them, and set them aside. Next, we'll take a 16mm spark plug socket and a 3/8 drive ratchet, and we'll go ahead and remove the spark plugs. Once they're broken with the ratchet, we can remove it, then spin them out backwards by hand. Now we want to pull the valve cover. In order to do this, I'll use a 10mm deep 1/4" drive on our air ratchet, and we have 4 nuts on the outer corners, and in the center 2 nuts on studs. And you want to be very careful not to drop anything in those cylinder holes. We're ready to pull the valve covers. We just want to be careful of the seals. Now we'll do the same to the rear cylinder head. I remove the hardware to make the process faster. Let's go over some information that will be helpful in doing the job. When you're turning the engine over, you want to make sure you always go clockwise. Going counterclockwise can possibly cause a timing belt to jump. That would be very bad times. When Honda designates cylinder heads, it's front and rear in accordance to how the engine's in the car. Front cylinder head, rear cylinder head. As far as cylinders, and you can always kind of remember this by taking a visual, the rear cylinder head is slightly forward than that of the front. That's why, since it's forward, this is the first cylinder that's farthest forward. So you have cylinder 1, 2, and 3 coming back, and on the front cylinder head, 4, 5, and 6 coming front to back. This is a cam gear that is always used for reference. So you can see the numbers on the gear. 1, 4, 2, 5, 3, and 6. Which is also the firing order. So when these numbers line up with the edge of the cylinder head in this same location, that cylinder is at top dead center, and that is when you want to make the valve adjustment. The spec on the clearance for the intake valves is 6 to 7 thousandths. On the exhaust valves, it's 7 to 8 thousandths. You can get feeler gauges anywhere. I choose to use these. They are snap-on. But the important part is that they're curved at the end. It's easier to get between the cam lobe and the rocker with those. The other thing you want is a 1/2" ratchet so you can turn the crank. This is the Honda adjustment tool. I don't know if you can get it anymore, so I did look it up, and I see on eBay and Amazon there are all sorts of various tools that work similar. This is like a socket that goes over the jam nut, and then there's a screwdriver end to adjust down to the clearance on the rocker. And then you use a 17mm open-end box to loosen and tighten the jam nut. We'll start by checking cylinder 1. I like to run 7 thou on the intake valves. The best way to check it is use one finger to push down on the rocker because it's spring-loaded, and then take the feeler gauge and send it in between the rocker and the cam lobe. That's just a little loose, so I'll take the tool, bring it down on the lock nut, and lock the tool into the screw. Once it's locked in, I'll take the 17mm wrench, open-end box. I'll hold the top portion to hold the screw from moving, and then I'll unlock it. I'll make the adjustment slightly, again holding the screw not to move. Go back down on the lock nut and check again with the feeler gauge, pushing down again with my finger. And we're good. Now we'll check the second intake valve. It's just a little tight, so we'll back off a little bit here. Again with the tool, locking in. Back off on the lock nut. I'm going to open up the adjusting screw just a hair, come back down, tighten and pull it off. We'll push this down. And we're good. The lock nut does have a torque spec of 14 pounds. And in all my experience, I have not torqued it down. I just go down nice and snug and have not ever had one back off. But of course, do what's comfortable to you. Another thing to keep in mind is this is 10mm. It is possible to do the job if you don't want to spend the money to buy the tool and use a 10mm socket and then a screwdriver. The problem is that this takes the job quite a bit longer because there's no way to hold the adjusting screw while you're tightening and backing off the lock nut. You can get the job done that way. In a pinch, if we've been at the track and I forget the tool or can't find it, I have done it. Moving to the exhaust valves, I'll do everything on the bottom side so it's easier to see. I like to set the exhaust valves at 8 thousandths. And that is a little bit loose. So again, same procedure. Put the tool in, lock it in, back it off, tighten it down just a little bit, and then tighten down the lock nut. Bring it back down. And then we're good. Check the other one. Push down the rocker, slide it in between the rocker and the cam lobe. That one as well is just a hair loose. Tool in, back it down, bring it down a little bit, pull it down, tighten, tool off, rocker down. Slide in the feeler gauge. That's good. After adjusting the valve clearance on cylinder 6, I'll turn the engine over back to cylinder 1, top dead center, and make sure that all the markings still line up. So we can see that both cam gears on this side line up, both cam gears on this side line up, and we are lined up with the TDC mark. That way we have verified that nothing moved. I always change all the valve cover seals and lubricate them with grease before reassembly. I also change the stud seals and lubricate them with grease as well. Then the valve cover goes down. We're ready to put back on the nuts in the center, then the 4 outer nuts. After that, we can put the spark plugs back in. The coils will go back in. The 2 nuts to secure the coils. Connect all of the coils to the connectors. Put the spacers on the center studs. Then the coil covers can come down. And you have the 4 bolts around the outer and the 2 nuts in the center. Well, all right, let's recap on what we've learned. For advice on women and life in general, contact Abel or JC. For advice on bad life decisions, contact me. And let's not forget, for minimal tooling costs and a little bit of patience and time, you can set your own NSX valve clearance and save a lot of money. See you next time.